Good evening, everyone. Thanks for coming out to Morven. By show of hands, how many, it's your very first time at Morven? Oh, wonderful. Well, thank you for coming. I'm Althea Brooks, and I'm Senior Director of Lifetime Learning in the Office of Engagement, and it's a pleasure to welcome you here this evening. We host an event or two each year at Morven and love coming out to Morven Farm. It's a property of the University of Virginia, so welcome. Before we begin, I want to thank the great Lifetime Learning team that worked really hard to put this evening together. And we had well over 100 registered and another 100 or so on the wait list. So I'm sad that we've got a couple empty seats right there because we had a number of people waiting and wanting to be here tonight. So we're glad you're here. But special thanks to Mary Lynn Musser. Mary Lynn handled all of the food and coordinating the logistics for this event. So thank you, Mary Lynn. Dana Mays, right here, she's our graphic designer, and she handled all of the social media, the marketing online, and emails so that you can learn about this program and attend. So thank you, Dana. And Susan Lynch is new to our team, and she's coordinating a number of one-day UVA programs, so be on the lookout for those. They fill up very quickly. We have a program coming up in just a week or two at the Paramount Theater, the Moscow Ballet. So that one filled up just like that. So they're small and intimate, but Susan is doing great work, and we're really, really happy to have her on our team, on the Lifetime Learning team. So thank you. And we also have a student in our office, Keandra Morris, and she helps us with research on faculty and tons of other things, social media, you name it, we give it to her to do. So thank you, Lifetime Learning team. Okay, so if you would, go ahead and silence the ringer on your phone. Go ahead and power down for an hour or so and just be with us. Also, we are sending to you this evening surveys, online surveys. So feel free to take a moment and fill those out. It does help us plan future events. So thank you in advance for that. Okay, we have the privilege of having a wonderful astronomer in our midst tonight who's going to teach us and then point out some things that we should be looking up at every night, really. Edward M. Murphy. Edward M. Murphy is the professor of astronomy in the Department of Astronomy in the College and Graduate School of Arts and Sciences at the University of Virginia. He earned his bachelor's degree in astronomy from the University of Illinois, Urbana-Champaign College, and received his PhD in astronomy from the University of Virginia in 1996. Edward Murphy was a postdoctoral fellow and an associate research scientist at Johns Hopkins University in Baltimore. He's worked on NASA Far Ultraviolet Spectroscopic Explorer, say that 5 times fast, called the FUSE. In 2000, he joined the faculty at the University of Virginia, where he continues to use the FUSE, along with radio telescopes, in his research on the interstellar medium. Mr. Murphy teaches courses on introductory astronomy and intelligent life in the universe to undergraduates, as well as seminars on how to teach astronomy to graduate students. He also offers evening classes for the local community at the historical Linder McCormick Observatory. He just told me he doesn't have a free Friday evening at all, ever. He also worked with the Science Museum of Virginia to develop the planetarium shows and exhibits. Mr. Murphy was named a Teaching and Technology Fellow in 2002 to 2003 and an Ernest Boots Mead Honor Faculty Fellow in 2003 to 2004. He received the Above and Beyond Faculty Award from the Office of Engagement in 2012. Our Night Sky. It's a popular course within the Great Course series. How many of you have taken a Great Course series, one of the courses? Edward Murphy taught the course called Our Night Sky, and he's quoted as saying, My goal is to introduce you to the beauty and wonder of the night sky and to give you a basic knowledge needed to feel comfortable navigating the sky. I think he's going to do that for us tonight. Please help me welcome and thank Edward Murphy for being our speaker for Engaging the Mind this evening. Thanks, Ed.
Okay. Thank you very much for having me here tonight. A couple quick things before I get started on the talk tonight is in the astronomy department, I run the education and outreach program. And so I'd like to invite everyone to come up to McCormick Observatory, the historic McCormick Observatory on grounds. McCormick Observatory was dedicated back in 1885, so it's been in continuous use by the astronomy department for 134 years. When it was finished, it was the largest telescope in the United States and the second largest lens telescope anywhere in the world, and we've been open to the public continuously since 1885. So now we open to the general public on the first and third Friday nights of every month. This time of the year, we're open from 7 to 9 p.m., so you're welcome to come up and take a look through that telescope as well. We're open to educational groups, so if you happen to be a teacher or know a teacher that would like to bring a group up, we're open to educational groups on the second and fourth Friday nights, and we have a special family night for families with young children whenever there's a fifth Friday of the month. So we do a lot of our outreach programs there on Friday nights. And I'd very much like to thank Althea and her team for putting this together tonight. So this is sort of a huge thing to put together, and it should be a lot of fun. I can't help whenever I do an astronomy program making sure that everybody learns something about the night sky before we get started. So that's why everyone has a map. And actually it's relevant to tonight's talk. There are a couple things that I would like you to know about the night sky. Most of you probably already know them, but it's always good to get a bit of a refresher. And the few things that I want to point out is Althea has provided everyone with this star map, which is the stars that are visible tonight. I'll talk more about that in a second. The best way to use a star map like this is the direction that you are facing gets held down at the bottom. So, for example, if you're facing south, you will hold it with south at the bottom and hold the star chart up like that. If you're facing towards the east, you will hold it with east down at the bottom and hold it up like that so that it will match the sky. So whichever direction you're facing goes down at the bottom, and that's why you'll notice the text is not all facing one direction. So the text in the north looks upside down because if you're facing north, you hold it with north at the bottom, and then that text is right side up. So that's a little bit about how to use the star map. An important thing to realize about star maps is up in the upper right-hand corner here, there are two important features of the star map. The first one that I want to talk about is these are the stars for December 2019, and you'll notice this is early December at 8 o'clock and late December at 7 o'clock. And yes?
Our maps say equatorial edition, and the one on the screen is northern hemisphere.
Oh, yep. So this is the equatorial edition is the one that if you live on the equator. So you'll have to take a trip to use this one. Sorry about that. There was a mix-up in sending maps today. So we really want the northern hemisphere edition. So you'll notice that the constellations are going to be slightly displaced between the two because this one is meant for the equator. But in any case, you'll notice that up here in the upper right-hand corner, it gives you a time. The reason it gives you a time that the star map is valid for is because the stars are constantly in motion. The stars rise in the east, move across the sky, and set in the west, not, of course, because the stars are moving, but because the Earth is rotating. The Earth rotates once a day, once every 24 hours, so the stars make a complete circuit of the sky once every 24 hours. And people often forget that the stars are constantly moving. So tonight, if you get the chance, go out. When we go out later on this evening, you should be able to see Orion up there in the sky. Take a look at where Orion is now, and then in an hour or two, look at it again, and you will see that Orion has distinctly moved. And an hour or two after that, it will have moved again. This plays a role in astronomy because, of course, nothing in the sky is ever sitting still. And that actually plays a bit of a role in the Star of Bethlehem. You have to keep in mind that nothing in the sky sits still. Everything in the sky is always moving because of the rotation of the Earth. A beautiful photograph of that is this one taken from the large island of Hawaii, the big island of Hawaii. That in the background here is the dormant volcano Mauna Kea. There's a huge observatory on the top of Mauna Kea. You can actually see people driving up to the observatory at night. You can see the car headlights there. And those are telescopes up on the top. And this was taken from Mauna Loa, which is the next big volcano to the south. And you'll notice the stars spinning around in the sky. And you will notice that the stars are spinning around a central point in the sky, and that is the North Star Polaris. And so all the stars are spinning around Polaris. They're rising in the east, moving across the sky, setting in the west. So here in the northern hemisphere, everything turns around the North Star Polaris. If you look carefully, you'll notice Polaris is not right at the center. It's actually slightly off-center, and that's true. The North Celestial Pole is not right on the star Polaris. It's a little bit off to the side. If you'd like to download these maps, you can just go to skymaps.com, and you can download these maps for free. You can get one for every month of the year, and you can get, as we've already learned, there's one for the northern hemisphere, one for the equator, and then one for the southern hemisphere as well. So that's where you can download these maps. The other thing to keep in mind when you look at this is you'll notice that it's for December 2019. And that's because not only do the constellations change during the night, but the constellations change with the seasons, and that's simply because of the Earth's revolution around the sun. As the Earth revolves around the sun once a year, the night side of the Earth is facing in different directions. So tonight, for example, in December, the night side of the Earth is facing so that in the middle of the night, Gemini, Taurus, and Aries will be high in the sky. You'll see in a minute here or in a little bit later that Aries plays a big role in the story I'm going to tell tonight. As the Earth moves in its orbit in January, it's Cancer, Gemini, and Taurus. By February, it's Leo, Cancer, and Gemini, and by March, it's Virgo, Leo, and Cancer. By March, the stars that we see tonight are already setting in the early evening sky. These are the stars that are up in the middle of the night. 6 months from now, when the Earth is on the opposite side of the sun will be in this part of the sky. We won't see these constellations at all. And 6 months from now, we'll be seeing Scorpius, Sagittarius, and Capricorn as high in the sky in the middle of the night. So the constellations change hourly during the night as the Earth rotates, and they change with the seasons as the Earth orbits around the sun. And both of those are important facts to keep in mind as we talk about the Star of Bethlehem tonight. As we go out tonight, if it's clear, I do have a green laser with me, so in addition to looking through a couple telescopes, we'll do some tours of the constellations, and I'll point out some of the bright constellations that are up there this evening. So now let's get on to the main story tonight, the reason that we're all here, which is the Star of Bethlehem, an astronomer's perspective. And I think really the best way to start this is at the beginning. And so let's start at the beginning, which is the Gospel of Matthew, chapter 2. In the time of King Herod, after Jesus was born in Bethlehem of Judea, wise men from the east came to Jerusalem, asking, "Where is the child who has been born, King of the Jews? For we observed his star at its rising and have come to pay him homage." When King Herod heard this, he was frightened, and all of Jerusalem with him. And calling together all the chief priests and scribes of the people, he inquired of them where the Messiah was to be born. They told him, "In Bethlehem of Judea, for so it has been written by the prophet. And you, Bethlehem, in the land of Judea, are by no means the least among the rulers of Judah. For from you shall come a ruler who is shepherd to my people Israel." Then Herod secretly called for the wise men and learned from them the exact time that the star had appeared. Then he sent them to Bethlehem, saying, "Go and search diligently for the child. And when you have found him, bring me word, so that I may also go and pay him homage." When they had heard the king, they set out, and there ahead of them went the star that they had seen at its rising, until it stopped over the place where the child was. And when they saw that the star had stopped, they were overwhelmed with joy. On entering the house, they saw the child with Mary, his mother, and they knelt down and paid him homage. Then opening their treasure chests, they offered him gifts of gold, frankincense, and myrrh. And having been warned in a dream not to return to Herod, they left for their own country by another road. Now after they left, an angel of the Lord appeared to Joseph in a dream and said, "Get up, take the child and his mother, and flee to Egypt, and remain there until I tell you, for Herod is about to search for the child to destroy him." Then Joseph got up, took the child and his mother by night, and went to Egypt, and remained there until the death of Herod. This was to fulfill what had been spoken by the Lord through the prophet, "Out of Egypt I have called my son." When Herod saw that he had been tricked by the wise men, he was infuriated, and he sent and killed all the children in and around Bethlehem, who were 2 years old and under, according to the time that he had learned from the wise men. So that is the primary source for the story that we're going to investigate tonight, which is the Star of Bethlehem, something that has fascinated people for literally 2,000 years. And so we're going to talk tonight about an astronomer's perspective on what the Star of Bethlehem might be. Right off, I need to say that I am not at all a biblical scholar. My apologies to anyone who was a religious studies major. You're welcome to correct me as we go along if I mispronounce something or say something wrong as we go along. But the first question is, what do we know from that story about the Star of Bethlehem? And so here are the things that we know about the Star of Bethlehem. The first thing we know is that it was significant to the Magi. It was significant enough that they left their home to travel for weeks, if not months, to go to a strange land. And it was significant because when they got to that strange land, they felt that this star heralded the birth of the King of the Jews. So whatever they saw in the sky, if it was a real physical phenomenon, it was significant to them. It wasn't just some minor event happening in the sky. So the first thing to know is it was significant to the wise men. The second thing to know about it is that it wasn't very bright. That the star that was visible in the night sky, interestingly enough, from that passage that I just read to you, was not noticed by Herod or his court astrologers, which all kings would have had in those days, nor was it noticed by the people of Jerusalem. So it's interesting that the star wasn't noticed by Herod, but it was noticed by the wise men. So I say here it was not very bright. Or, actually, maybe it was, because there are later writers, in particular in the Epistle of the Ephesians and the Proto-Evangelium of James, actually claim that it shone with incredible brilliance. So, in fact, maybe it was a really bright star. They disagree on whether it was a dim star or a bright star in the night sky. The star was visible for a long time. It wasn't just something that happened very quickly. And we know it was visible for a long time because the Magi see it from their home, which presumably, based on their reading and based on the history of the area, was likely east of Jerusalem. So they see the star. They undertake a journey that is going to last many weeks or months to get to Jerusalem. And then they're overjoyed at seeing the star after they meet with Herod in Jerusalem. So they saw the star. They saw it again. Unfortunately, the original Greek, it's not clear whether when they say they saw it again, did they mean that they had been seeing it continuously the whole time, or whether they saw it, it disappeared and reappeared. It's not at all clear from the context. But in any case, this wasn't something that just appeared in the sky for a few hours and disappeared, or appeared for a day and disappeared. This was something that was visible for a substantial amount of time. And then the last thing is the star was visible in multiple directions. So it's not like a fixed star in the sky. They had seen his star in the east. It's not clear again from the language, which that meant, were they in the east when they saw the star? Did they see the star in the eastern sky? We'll see in a minute there's a debate when they said in the east. Did they mean that they saw the star as it was rising? But after leaving Herod and heading southwest towards Bethlehem from Jerusalem, they said, and lo, the star, which they saw in the east, went before them till it came and stood over where the child was. So these are the clues that we have from the Gospel of Matthew as to what was going on in the sky. The last point that I want to make about it is that the author of the Gospel was very specific in using the single word aster to describe the star. Now, some people have commented over the years that he used aster in the same way that you and I use fish. Right? I can have a fish for dinner, or I can talk about all of the fish in the sea. I use the same word to mean both singular and plural. And the belief by some people is that the word aster used here could mean multiple stars, could even mean planets in the sky. However, it's important to know that the author had at his disposal two other words that he could have used to describe those things. Asteres, which is the plural of aster, which means stars. So if it was multiple stars in the sky, he could have used asteres. Or he could have used the word for planets, which is planes aster or asteres planatia. And both of these words are actually the origin of our word planet. Planes aster means a wandering star, or the same thing over here, a wandering star. And that's what they called the planets in the sky in ancient times. Because when you look in the sky, the planets, for the most part, look like the stars, except that they wander around. As they orbit the sun, the planets move through the constellations of the sky. They don't move through any constellations. They specifically move through 12 constellations of the zodiac, as do the sun and the moon. And in fact, in the times of ancient Greece, the sun and the moon were considered planets as well. So the sun, the moon, and then the 5 visible planets, Mercury, Venus, Mars, Jupiter, and Saturn, for a total of 7 planets in the sky, which, in case you weren't aware, that's why we have 7 days in our week. And each of the days of our week is ruled by one of the planets in the sky. Sunday, obviously, Monday is the moon's day. It's a little harder with Tuesday unless you know French or Spanish, for example, and then you can work out the days of the week from there. Tuesday is Martes, Mars's day. Wednesday is, in Spanish, it's miércoles, which is Mercury's day. Thursday is jueves, Jove is Jupiter's day. Friday is viernes, which is Venus's day. Saturday is obviously Saturn's day, and then we're back to Sunday again. So that's where the 7 wandering planets gave us the 7 days of the week up there. But he specifically uses the single word for star, so we have to keep that in mind as we go through this as well. So if we want to understand what it was, if it was, again, a real physical phenomenon, I'll talk about that in a few minutes. Maybe it was a myth or something else. But if we want to find something in the sky, we need to know when to look. So the very first question we have to answer is, when was Jesus born? And then the obvious answer to the obvious question of that was, well, wasn't his birthday simply December 25th in 1 BC, right? We are in the year 2019, right? And 2019 is supposed to be 2019 years after the birth of Jesus. And so the answer to that, of course, is, with many things in this story, is very complicated. But it's worth delving into for a minute because it's something that we use every day of our lives. And it's worth understanding the origin of that number for a second. So the origin of this number actually dates back to about the year 525. And it's Dionysius Exiguus was working in Rome. And he was compiling there's a statue of him at the National Cathedral in Washington. Dionysius Exiguus, or his name, Dennis the Little, is what it stands for. Dennis the Little was in the process of publishing a table of dates for Easter. So these early Christians needed to know when Easter would be. And the rule for Easter is rather complicated. The rule for Easter is it is the first Sunday after the first full moon after the vernal equinox. So it sounds kind of easy. You wait for the vernal equinox, then you wait for the full moon, and then you have Easter as the next Sunday after that. The problem is, you need to be able to predict when Easter will occur in the future. You can't just wait for the spring equinox to occur, which, by the way, is not completely obvious to most people when the equinox is happening, but there are ways to measure that, and then wait for the full moon and then call it Easter, because you have to plan months in advance for Lent and all of the other Christian holidays that lead up to Easter, not to mention the fact that you want everybody in the world celebrating Easter on the same day. You want everybody to know ahead of time when Easter will be. So the early Christians used tables of the dates of Easter that would tell them when Easter would be. These tables were not easy to calculate because you were having to account for the vernal equinox, you were having to account for the phases of the moon, and then you were having to account for the Julian civil calendar that had 7 days in the week by this time. In addition, it's a lot more complicated because that is one calendar that was in use. There was also a liturgical calendar that Dionysius was trying to bring into order as well. So he's trying to match up all these calendars, the phases of the moon, for example, and interestingly, not the real phases of the moon, but the phases of the moon based on other tables that people had written. So as he's doing this, he's actually continuing a job that was begun by Cyril of Alexandria, who died in 444. So Cyril of Alexandria had published dates that went all the way up until about 530, and Rome realized that these tables were running out, and so they needed somebody to compose new tables. So Dennis the Little got the job of composing these new tables. So he was working on this, but the problem was that Cyril of Alexandria had counted the years since the time of the Emperor Diocletian. And the problem for Dionysius Exiguus is that Diocletian had persecuted Christians. And he didn't want their calendar based on an emperor who had persecuted Christians. So he calculated that Christ had been born 525 years earlier, and that became AD 1, Anno Domini Nostri Jesu Christi, which is the year of our Lord Jesus Christ. Now, I think it's worth reading the actual passage that he wrote in the year 525, just because, again, we use this number every day. And so this is from volume, if you're interested in it, it's volume 67 of the Patrologia Latina, which is a whole compilation of early Christian texts that exist. And this is what Dionysius Exiguus wrote in the year 525. Bishop Cyril began his first cycle with the 153rd year after the Diocletian era, and he ended his last cycle at the 247th year after the same tyrant. But we will not link the memory of this ungodly persecutor to our new cycles. We choose rather to designate time from the incarnation of our Lord Jesus Christ, because both the origin of the redemption of mankind and the source of our hope, namely the passion of our Redeemer, shall in this way be more manifest. That paragraph is the origin of our year numbering scheme that we have used for the last 1,500 years. Problem was, it wasn't straightforward to figure out when Christ was born. He had many of the same problems that we're going to encounter tonight. So first of all, he doesn't make it clear how he calculated that it had happened 525 years earlier. Historians have since worked on this, and they have an idea of what he was doing and how he did it. For those that are curious about it, he knows there's a quite good statement in the Gospel of Luke about when John the Baptist started his ministry. We know that Jesus started his ministry right after that, and the Gospel tells us that he was about 30 years old. And so if you assume that he was about 30 years old, then in the Gospel of Luke, it tells us it was in the 15th year of the rule of the Emperor Tiberius. You can back all that off and figure out when Jesus was born. The problem is, he was using lists of Roman consuls, and there were errors in those lists. There was also confusion in the lists of Roman emperors that he was using. He may have, in fact, made a slight mistake himself in that he neglected 4 years that Augustus Caesar ruled under his family name of Octavian. So there were some mistakes made along the way. 525 probably wasn't the right answer. As best as we can figure out today, he left out about 7 years, which means 1 AD should have been about the year that we call 7 BC. So a modern estimate places Jesus' birth around 7 BC. It's interesting to note, by the way, that Dionysius Exiguus did not invent BC. He did invent AD, but he strictly meant this as counting years from the birth of Christ onward. He was not a historian. He was not trying to figure out what happened before Christ was born. So BC is a much more modern invention going back before that time. And as all of you are aware, but it's worth mentioning because kids make this mistake all the time, BC is English for before Christ. AD is Latin for the year of our Lord. It does not mean after death, because otherwise there'd be about a 30-year period there that's neither BC nor AD. But that's a very common misconception. All right, so that's how we got our years. How about December 25th? Is that the birthday of Jesus? Turns out, of course, it's probably not. The first reference to a nativity celebration, the celebration of Jesus' birth on December 25th, comes from the calendar of Philocalus in year 354, AD 354. So that's the first time that we see it written on a calendar that Jesus' birth is December 25th. There are other traditions that probably predate this, that the birthday was celebrated on December 25th, but this is the first time we see it on an actual calendar. The other thing that is on that day, on that very same calendar, is a well-known Roman holiday, Dies Natalis Solis Invicti, the birthday of the unconquerable sun. So this was a holiday that celebrated the victory of light over dark, and it was created by Aurelian in around AD 275. This day, and in fact, the unconquerable sun, had a number of groups that worshipped the unconquerable sun in various parts of the Roman Empire. So this was a rather large holiday in the Roman Empire. And it's likely that early Christians co-opted that day for a few reasons. By the way, first of all, it may not be obvious why December 25th for the birthday of the unconquerable sun. Well, back in those days, thanks to the calendar that Julius Caesar had set, March 25th was the vernal equinox. June 25th was the summer solstice. September 25th, on or around September 25th, was the fall equinox. So December 25th was the winter equinox. And the winter equinox is when the sun is at its lowest in the sky. When the days are shortest, the sun barely gets above the treetops. It's the birth of the unconquerable sun because the sun stops sinking lower and lower and then starts to rise higher and higher in the sky. And you can imagine that symbolism of the brightest light, the light that gives us life on Earth, sinking lower and lower in the sky till it reaches at its lowest, and then it's often referred to as the rebirth of the sun when the sun starts coming back. You can imagine that that imagery was attractive to the early Christians, especially because they were trying to attract pagans and Gentiles to Christianity. It also worked out really nicely because Christians celebrated the conception of Jesus on March 25th, which is an even older holiday in the Christian calendar. Probably goes back 100 years or more before the celebration of Christmas on December 25th, called the Feast of the Annunciation. And that works out nicely because if the conception was on March 25th, 9 months later we have the birthday on December 25th. So that was probably another driver towards December 25th. But the truth is we're stuck in a situation where we don't know what the year was, and we don't know what the day was that Jesus was born, so it's hard then to know what's going on in the sky. But fortunately, the Gospels, or maybe unfortunately, as we'll see in a second, give us some hints as to what was going on. So we've already heard the Gospel of Matthew, and the most important thing in the Gospel of Matthew was that Jesus was born in the time that Herod was king. So we have to, whatever's going on in the sky, it should be when Herod is king. I was going to mention very briefly here, so some of you might have heard the story that Christmas is based on an old Roman holiday called Saturnalia. It's likely that many of our modern traditions around Christmas derive from Saturnalia, but Saturnalia itself wasn't the origin of Christmas Day. So Saturnalia was an autumn festival that was held, obviously, to honor Saturn. It started on December 17th, and in various years or various times in the history, it lasted different amounts of time. Initially, it was probably just 1 day, and then it grew to 3 days, and then it grew to 7 days. But it was never really more than 7 days, which means it was always over before December 25th. It was a public holiday, so you couldn't conduct business on that day. But there was public feasting, there was gift giving, there was generosity to the less fortunate, there was a lot of partying. Slaves were allowed to gamble on that day, which they weren't allowed to do the rest of the year. There was a general carnival atmosphere. And there was also the famous story about Saturnalia having role reversals, where the masters would serve dinner to the slaves at their table. They'd provide a banquet for the slaves that evening. So you can see some of the things today that we think of as traditional Christmas time were probably co-opted from Saturnalia. As Christianity became more dominant, people loved there's an author in Roman times that says Saturnalia was the best time of the year because of all the partying that went on. They probably took some of that and brought that over into Christmas as Christmas was starting to dominate over Saturnalia. So we're going to have to look to the New Testament here to try and figure out the dates, at least the dates that we should be looking for something in the sky. So we've already seen Matthew, so let's see what Luke has to say about this. So in the Gospel of Luke chapter 2, I won't read the whole thing. I'll just read the first three phrases in chapter 2. And the first one is, in those days, a decree went out from Caesar Augustus that the whole world should be enrolled. This was the first enrollment when Quirinius was governor of Syria. So all went to be enrolled, each to his own town. And then it goes on to say that, of course, Mary and Joseph went to Bethlehem to be enrolled there. Here's the problem. Let's put together everything we know from the Gospels and try and figure out a year that Jesus was born. And so it's going to take a minute to work through all of this. So the first thing is Matthew tells us that Herod was the king. We know pretty well when Herod died. So a Jewish historian that was working about the year 70 or 80 A.D. by the name of Josephus Flavius wrote a history of the Jewish people. And he says that Herod died after an eclipse of the moon and before Passover, and that there wasn't much time between the eclipse of the moon and Passover. Now, eclipses of the moon can be predicted really well, so you can go back and do that, and it turns out that happened twice in short order. One was in about 4 BC, and one was in about 1 BC. The 4 BC date is favored by historians because there is other evidence from history that by 3 BC, Herod's kingdom was being split up amongst his remaining sons, And so it's likely that Herod died in 4 for his kingdom to be divided in 3 BC. There are historians who argue, though, that because the eclipse in 1 BC was total and really spectacular, and the eclipse in 4 BC was partial, that maybe this was the eclipse that Josephus Flavius was referring to. We don't know, but most historians fall with favor that it happened in 4 BC. Here's the problem. Luke tells us that Quirinius was governor of Syria. Quirinius doesn't become governor of Syria until 6 AD, and he rules from 6 to 7 AD. And those two don't overlap in any way. And so we have the first of what turns out in this story to be many conflicting pieces of evidence as to which one you want to believe. Was Herod the king, or was it during the census taken by Quirinius? Now, lots of people can wordsmith this because of various translations. And so one way you can wordsmith it is it said this was the first enrollment when Quirinius was governor of Syria. The word that they used here for first could also be the word that means prior instead of the word first. And what it could be is this was prior to the enrollment. So people have argued that what they just meant is it was before Quirinius' census. We can look, we're told that it's when Caesar Augustus said that the whole world should be enrolled. So that's, Rome was very good at record keeping. So we have the record of when Caesar Augustus did that. And let me get the dates here. So Caesar Augustus conducted censuses in 28 BC, 8 BC, and 13 AD. So the only one that matches up with Herod being king is the 8 BC, and then the one that's much earlier in 28 BC. The problem with this one is Augustus Caesar would have been enrolling Roman citizens. He would have been counting Roman citizens. He would not have been interested in people who were not Roman citizens. And these people at the time, of course, were not Roman citizens. So he wouldn't have been enrolling them. There are other records of other censuses at the time. Tertullian, who's writing in 200 AD, records a census in Judea by Sentius Saturnius, who ruled from 9 to 6 BC. So maybe if Tertullian, again, who's writing 200 years later, maybe he had access to records that we no longer have access to, and he's recording that there was this census in Judea by Saturninus, and so Saturninus was legate of Syria up until 6 BC. Other things that we have is we know when John the Baptist began his ministry. We know how old John the Baptist was at the time. The best evidence we have from the Bible is that Jesus was born about 15 to 16 months after the conception of John the Baptist. So that would put his birthday in here. This is also the same thing, roughly, that Jesus is about 30 years old when John the Baptist begins his ministry, which was in the 15th year of Tiberius's reign. So if we assume that 30 years means that he's somewhere between, say, 26 and 34, we can limit it to this range. So if we put all this evidence together, we can see that it is, in some cases, mutually exclusive, but it seems to favor a birth sometime between about 8 BC, 9 BC, or 8 BC, down to all the way about 5 BC, as to the birth of Christ from the history that we have in the books. So at least now we've narrowed the year ranges, and we can start looking for interesting things that happened in the sky between 8 BC and about 5 BC. So that's what we're going to do. All right, so what are the 5 explanations that I'm going to go over tonight for the Star of Bethlehem? Here they are. We're going to go over each one in a little bit of detail. So the first one is that it was a miracle. The second one is that it's a pious myth or a story or a Jewish form of religious myth called midrash. Or it could have been an actual event in the night sky, and we'll talk about those 3 possibilities in a few minutes. But let's talk about the first one, the fact that it's a miracle. Science, and I'm a scientist, is concerned with finding natural explanations for natural phenomena. We look to explain the solar system, we look to explain the universe using natural phenomenon, using natural explanations. If it's truly a miracle, it is outside the world of science, because by definition, a miracle is supernatural. And it's outside the realm of science, and then it's a matter of faith, and it is not a matter of science, and then there's really nothing more I can say about it. If you believe it's a miracle, I can't help you there to tell you what it was, because then it was truly miraculous. It was nothing that we've ever seen since. It's nothing that science can explain. So that's the idea of a miracle. The second one, I think the one that many religious scholars would point out, is that it could be a pious myth or a midrash. So a lot of people interpret the nativity of Matthew to be a pious myth, an ancient form of Jewish story that popularizes and explains a biblical account. In order to understand why this is prevalent, we have to understand who Matthew was and why he was writing his gospel and when he was writing his gospel. So the first thing to know is that Matthew, the writer of the gospel, is not the apostle Matthew. He did not live in the time of Jesus. He did not know Jesus. He was writing, in fact, about 50 to 60 years after the crucifixion of Jesus. He was writing about AD 80 to 90. So Matthew was not a first-hand account of what happened to Jesus. The best we can put together from the evidence we have of all of his early writings, this is a 3rd century papyrus that contains part of Matthew chapter 26. This is how biblical scholars have put together the Gospel of Matthew, especially the early versions of the Gospel of Matthew over time, is looking at fragments of papyrus like this. And what they've been able to gather from this is that the author was likely a Greek-speaking Jewish Christian, we'll talk more about that here in a second, who lived amongst Gentiles and Jews in Syria, most likely in the city of Antioch up in Syria. I already mentioned it was not Matthew the Apostle. What do I mean by a Jewish Christian? At this time, AD 80 to 90, Christianity was starting to break away from Judaism. At this time, people who were worshiping Jesus believed that Jesus was divine. And this was breaking with Jewish tradition. And so Matthew had a specific reason for writing the gospel. And the specific reason that he was writing his gospel was to establish the divinity of Jesus. He was not a historian. It's important to understand that Matthew was not writing his account of the gospel in the sense that a historian would write an account of the life of Jesus. Matthew was instead demonstrating the divine nature of Jesus was his primary concern. Matthew got his information from 2 sources. Biblical historians have looked at the Gospels and found that Matthew largely drew on the Gospel of Mark, which was written probably about 10 years earlier than the Gospel of Matthew was written. And we know that because a good fraction of the Gospel of Mark is contained in the Gospel of Matthew. A good fraction of the Gospel of Mark is also contained in the Gospel of Luke. That's why they're called the Synoptic Gospels. They're all similar to one another. They all had a similar source, which was Mark. But that said, Matthew contains a lot more than Mark did, and he has a lot of sayings that Jesus said in his lifetime. Interesting, Luke has those same sayings of Jesus from Jesus' lifetime, and so the 2 of them were relying on a source that Mark didn't have, and that source is called the source Q. It comes from the German word for source, but that's known as the source of a book of Jesus' sayings called Q. So Matthew was writing from Mark. He was writing from this other source called Q, and then he also had a 3rd source, and that 3rd source is just known as M, and that source was either Matthew himself or some source that we don't know about, because there are things that happen only in Matthew that don't happen anywhere else. And one of those is the Star of Bethlehem. His is the only mention in the New Testament, in the 4 Gospels, I should say, of the Star of Bethlehem. So he was trying to demonstrate the divine nature of Jesus, and he shows Jesus as the Son of God from birth. And in particular, he wants to show that Jesus fulfills a whole bunch of Old Testament prophecies. And this is where the Jewish term midrash comes in. So midrash are these stories that are meant to build on an ancient story in the Old Testament. One of the ones that Matthew builds on, for those that don't remember your Old Testament, is the oracle of Balaam. So Balaam was a famous seer. He was summoned by King Balak, who was the king of Moab, to put a curse on the Israelites. And he tricked the king of Moab. At this time, the Israelites were being led out of Egypt by Moses. And rather than putting a curse on the Israelites, in fact, he gave them 3 blessings. He responded with the blessings, and one of them was, "A star shall advance from Jacob, and a staff shall rise from Israel, that shall smite the brows of Moab and the skulls of all the Shuttites." So he thwarted King Balak by predicting, not cursing the Israelites, but actually predicting their future greatness, and that a star would rise out of Israel that would rule the world. And this story was used amongst Judaism for centuries as a prophecy about the coming Messiah. And so Matthew wanted to make sure that this prophecy, which had been used for hundreds of years to predict the coming of a Messiah, was used to establish that Jesus was that Messiah. And so that's why that story may appear. That's one of the reasons that it's believed to be Midrash. Another thing that's in favor of a pious myth is that there are lots of stories of ancient heroes having stars appear in the sky at the time they are born. So it may be that the Star of Bethlehem was simply meant to establish that Jesus was one of these great heroes for whom stars had appeared in the past. So those are those two possibilities. The last three possibilities are that it was an actual event in the night sky, either a nova or supernova, a comet, or a planetary alignment. And so we'll go over all three of those real quick. So in order to understand which of those, if any of them, would have been important, we need to know a little bit about the Magi themselves. So interestingly, nowhere in the gospel is it mentioned how many Magi there were. By tradition, we think of 3. By much later tradition, they were given names. But in truth, the gospel tells us nothing about how many there were. There could have been 3, there could have been 12, there could have been 21. We don't know. The only indication of their origin is that they came from the east. So they were most likely, historians believe, astrologers that came from Mesopotamia or Babylonia. So here we have Jerusalem down here. We have Babylonia and Mesopotamia between the Euphrates and the Tigris right there. They probably came from the east, an area where astrology was widely practiced, although truly astrology was practiced all over. At that time, as astrologers, they likely practiced Greek astrology. And the reason they would have practiced Greek astrology was because of Alexander the Great. So Alexander the Great conquered this part of the world in 330 BC, brought Greek culture across the Middle East, and at this time, Hellenistic astrology or Greek astrology was used primarily. So they would have been using some kind of Greek astrology. So the first one is a supernova. Could it have been a nova, which means new star, or a supernova in the night sky? This idea was first put forth by Johann Kepler. So if you're interested in the origin of the Star of Bethlehem, you're in good company, because one of the greatest astronomers of all time, Johann Kepler, was interested in exactly the same question as to what was the Star of Bethlehem. And Kepler was intrigued by this because of an event that happened in the year 1604. Kepler was looking at a planetary alignment of 3 planets in the sky, Jupiter, Saturn, and Mars. The 3 of them had a very close pass together in the skies. Some of you might have seen on Thanksgiving Day, if you got the chance to go outside, or a couple days before Thanksgiving, there was a beautiful alignment of the moon and Venus and Jupiter in the western sky right after sunset, right around Thanksgiving Day. They were really low in the sky, but if you were out for a walk on Thanksgiving Day, you might have seen them, or a couple days before that. But in any case, Kepler was keeping an eye on these 3 planets that were very close to one another in the sky in 1604. And amazingly, right in the middle of these 3 planets in the sky, a new star appears in the sky that is brighter than any of the 3 planets. This is the constellation of Ophiuchus the Doctor. So there's Scorpius the Scorpion down there, Sagittarius the Archer right here, Ophiuchus the Doctor, and in the foot of Ophiuchus, a new star appears right in the middle of these 3 planets in the sky. Now, Kepler was a scientist. He invented our laws of planetary motion. He got them exactly right. He was the first person to mathematically understand how the planets actually orbit the sun. But Kepler was also very mystic, and he believed that it was this conjunction, as it's called, this grouping of 3 planets, that actually brought this new star into being. And he said, maybe that's what caused the Star of Bethlehem. Maybe these 3 planets coming together created the new star, and that was the Star of Bethlehem. So he calculated when these planets come together and found out that about every 800 years, these planets come together. And doesn't that work out great? Because this was the year 1604. 800 years earlier was the year 800. 800 years before that was around the year 0. So he was able to do a more precise calculation and found that it wasn't the year 0. It was around the year 7 BC. There was a triple conjunction of Jupiter, Saturn, and Mars in the sky. And he said, if this year, 1604, a supernova appears maybe with that triple conjunction in 7 BC, that a new star appeared in the sky. That must have been the Star of Bethlehem. He wrote it in this book called Stella Nova, the New Star, and it was about the birth of Jesus. So that's the book that Kepler wrote. So let's talk about what supernova is for a second in the modern understanding of a supernova, because the thing is, Kepler was a mystic. He didn't know what supernova were. We know what they are today, and they are absolutely not caused by a triple conjunction of stars in the sky. It was completely accidental that Kepler saw this one in that part of the sky when he did. So what is a supernova? A supernova is at the end of the life of a star. There's two different kinds. When really massive stars reach the end of their lives, their core implodes, and it blows the outer layers off the star, creating a titanic explosion. And for a month or so, that exploding star can actually outshine the billions, or in this case, hundreds of billions of stars that are in the parent galaxy. There are also another kind of supernova, which is what happens when you have a dead core of a star called a white dwarf star, and it's being orbited by a companion. And that companion is dying, and it has puffed itself up into a red giant star. And as it puffs itself up into a red giant, the outer atmosphere of that dying star gets funneled on top of the white dwarf, and the white dwarf builds up so much mass so quickly that it collapses and creates a supernova in the sky. So there are these two different mechanisms for creating supernova in the sky. We can differentiate them today, but if you just see a bright new star in the sky, you know it's a supernova. With the eye, you can't tell which one it was. But today, by breaking the light into its component colors, you can tell what it was. So supernova appear in galaxies all the time. This is a supernova here in the nearby galaxy M101. Supernova have been recorded throughout history. Chinese astronomers used to keep meticulous records of these new stars appearing in the sky. So, for example, in May of 1006, a supernova exploded in the constellation of Lupus, the wolf. It was bright enough to be visible in the daytime sky for a month. Imagine going out and seeing a new star so bright that you can see it in the daytime for a full month. On July 4th in the year 1054, a supernova exploded in our modern constellation of Taurus, the bull. Today, when we look there, we see the exploded remains of that star. It's called the Crab Nebula, because if you squint and look at it just right, you can kind of make out the outline of a crab there. But that was a star that literally exploded. We know the exact day because the Chinese astronomers did such a good job of keeping records that we can track it to the fact that they first noticed it on July 4th in the year 1054. Of course, the star didn't actually explode then. It's about 5,000 to 6,000 light years away from us. So the explosion actually happened about 5,000 to 6,000 years before that. But we didn't know that until the light got to us in the year 1054. I think that's really interesting because this supernova exploded about halfway between us and Jesus, right? If Jesus is around 0, we're in 2019. 1054 is about halfway back in between. Youngsters today will live to see the 1,000th anniversary of this supernova. Other famous supernova occurred in 1181, 1572. The last bright one was Kepler's in 1604. Here's the thing that's really disappointing to astronomers. The last bright supernova in the sky was Kepler's supernova in 1604. The telescope was invented in 1608. So we've not even been able to see a bright supernova with a telescope. We've all been waiting 400 years for a bright supernova. I'm holding out hope that one will appear in my lifetime, but it's been about 400 years since we had a bright supernova in our galaxy. Now, we do see supernova in other galaxies. Our Milky Way galaxy is a companion galaxy called the Large Magellanic Cloud. And back in 1987, a star exploded in the Magellanic Cloud. It was not visible here in the northern hemisphere. You had to be way down in the southern hemisphere to see it. But this is a giant star-forming region called the Tarantula Nebula that is in that nearby companion galaxy. And if you look very carefully in here, you can see the star that's about to explode. So pick the star you think is about to explode. How many people picked that one? No. Yeah, I was going to say, if anybody picked it, you should be a professional astronomer, because professional astronomers had no idea that that star had reached the end of its life and was ready to go supernova. See, the problem with stars are, when we study their surface, we can't tell what's going on deep down inside the star. We can know roughly where it is in its lifetime, but we can't tell whether it is 1,000 years from dying, 1,000,000 years from dying, maybe 100,000 years from dying, or whether it's going to die tomorrow. The surface features that we can actually observe can't give us that kind of level of detail. So we knew that this was a massive blue star, but we did not know that it had reached the end of its life and was going to explode as a supernova back in 1987. So maybe it was a supernova. The problem with the supernova explanation is a twofold. The first one is that supernova don't move around. When a supernova happens in the sky, it's in that part of the sky. Generally, you wouldn't say that it would be seen in the east, and then possibly in the west, and then maybe in the south. So supernova don't move around. In addition, if we look at what Greek astrologers were interested in, there's no evidence that Western horoscopes, Greek horoscopes, paid any attention to these guest stars. They were so infrequent and so unusual that they weren't really prepared for them, and they didn't have anything that indicated the blessings of a new star. And so it's unlikely, I think, that was it. One of the more famous things that has been put forth as an explanation for the Star of Bethlehem is a bright comet in the night sky. This is the Adoration of the Magi by the Italian artist Gatto. And you can see it's a famous depiction of a comet up above the nativity scene here. He painted this around the year 1300, and it's believed that he painted it just after 1301 because Halley's Comet was in the inner solar system and had a very bright appearance in the night sky in the year 1301. And he was probably inspired by that to realize that maybe a comet was what they were talking about with the Star of Bethlehem. And so he painted this famous painting on a wall of a chapel. So it's one of the most popular ideas behind what the Star of Bethlehem might be. It was proposed as early as the 3rd century. It's actually the earliest theory for what the Star of Bethlehem might have been. The nice thing about a comet is the tail of a comet could literally point the way to Judea. Comets usually have 2 tails to them. A comet, by the way, I'll come back to this in a second. There's another picture of a comet. So some of you might remember Comet West in 1976, a very bright comet. More of you might remember Comet Hale-Bopp in 1996, which was the last really bright comet that we had here in the northern hemisphere. There was a really bright one like this that was visible in the southern hemisphere a little over 10 years ago called Comet McNaught. But Hale-Bopp was the last bright one here in the northern sky. Comets typically have 2 tails to them. The yellowish-colored tail is called a dust tail. It's made up of little tiny chunks of rock and ice. A comet is actually a dirty snowball or an icy dirt ball, depending on the comet. It's either mostly made of ice with a little bit of rock and dust mixed in, or it's mostly made of rock and dust with a little bit of ice mixed in. Probably actually depends on how old the comet is. When they were young, they were probably mostly ice with a little bit of rock and dust. And as they go around the sun, every time the ice melts, as the ice sublimates, I should say, it goes straight from a solid to a gas. As that ice sublimates, some of the particles of some of the particles of dust and rock are then shed from the comet, and the wind from the sun, called the solar wind, pushes those particles away. The solar wind is simply particles that are given off by our sun. It's moving at many hundreds of kilometers per second, and as it hits those little grains of rock and ice, it just pushes them away and forms the beautiful yellow tail. The yellowish-white color actually comes from the fact that it's just reflecting sunlight. It's not giving off any light of its own. Those little tiny grains of rock and ice are just reflecting the light from the sun, so it has the same color as our sun does. A comet will also have an ion tail, which is usually blue in color. These are individual atoms. These are chunks of rock and ice. As the ultraviolet light from the sun hits the water and hits the carbon in the nucleus of the comet, it will break it down into individual hydrogen and oxygen and nitrogen and carbon atoms. Now, those atoms are so lightweight that they get blown directly away from the sun. These particles are left in the orbit that the comet was in, but these particles are blown directly away from the sun, and the ultraviolet light from the sun excites them to glow, and they typically glow with that beautiful blue color. If you have a really bright comet with the naked eye, you can see both tails. Most comets, the human eye can see the yellow tail much easier than the blue tail, because the blue one, as you can see, is a lot fainter. But comets have the advantage that they're moving. A really common misconception about comets is that they streak across the sky and they're gone in a few minutes. That's a meteor, which is a little tiny piece of rock or dust burning up in the atmosphere. The thing to know, meteors actually often do come from comets. This trail rock and dust that's left behind, if the Earth passes through that debris trail left behind, we'll get a meteor shower. So meteors often do come from comets, and they streak across the sky in a second. But comets don't do that. Comets can take a long time to orbit the sun. And they typically orbit the sun on highly elliptical orbits where they plunge in close to the sun, warm up, melt, put on that beautiful tail, and then they come out from the sun where they cool off, and then they do this over and over again. Here's the orbit of Halley's Comet. Halley's Comet comes all the way in almost to the orbit of Mercury. It goes all the way out to the orbit of Neptune in the outer solar system and does that every 76 years. So Halley's Comet was last back in 1986. Put it on your calendar. It'll be back in 2061. So if you missed it in 1986, you can see it in 2061. So Halley's Comet goes around every 76 years like that. And as I said, the nucleus, the actual ball of rock and ice down there, dust and ice and rock down there, that's typically about 10 kilometers or about 6 miles across. Now that we live in the 21st century, we have visited a number of comets over the time. In 1986, famously for the first time in human history, we sent a spacecraft, the European Space Agency sent a spacecraft to fly by Halley's Comet. And as it flew by Halley's Comet, it took this picture of the nucleus of Halley's Comet. So that is the big ball of ice and rock and dust. It was 1986. We were just learning how to do spacecraft flybys like this. They were going at very fast speed, so it's not a very crisp or clear image. It did not go into orbit around Halley's Comet. It flew past the comet at very high speed. The spacecraft was actually called Gatto in honor of the Italian artist who painted that scene that I showed you just a second ago. Today, we've actually put spacecraft in orbit around comets. This is another European Space Agency mission called the Rosetta spacecraft. And it spent over a year in orbit around the comet Churyumov-Gerasimenko and actually put a lander down on the surface. You might remember this a few years ago. The little Philae lander actually landed down on the surface of the comet and returned pictures from the surface. So those are what comets are today. But they do have the advantage that they do fulfill some of the things that we talked about. When they had heard the king, they set out, and there ahead of them went the star they had seen at its rising, until it stopped or stood over the place where the child was. And when they saw that the star had stopped, they were overwhelmed with joy. The advantage to comets is because of that tail, they really can point to a location on the ground. This is the comet that I mentioned a few seconds ago, Comet McNaught, that was visible in the southern hemisphere about 10 years ago. Another view of another comet there. But you can see now why with comets that they might fulfill this prophecy that it pointed the way that they should go. On top of this, because comets are orbiting the sun, they really do move through the sky. A comet can be seen in the east, and then a few months later it can be seen in the west. As it orbits the sun, it will move through our sky. I'll show you an example of that here in a second. So what comets were visible back at the time of the Nativity? Well, I'll come back to this one in a second. Well, I'll go over this now. I'll come back to that in a second. So one problem with this idea of a comet is that in ancient times, comets were usually used not to predict the beginning or the rule of a king, but the death of a king. So in ancient times, people usually feared comets because it meant that something bad was going to happen. By the way, we don't believe this anymore, but you still use the terminology of it. It was believed in Roman times that comets brought disease to the earth. And it was the influence of the comet that brought the disease. And one of the worst diseases that we have every year is influenza. And the word influenza comes from influence of comets and this belief that comets brought disease with it. So the thing is, I suppose most times when a comet was visible in the sky, it predicted the death of a king. So if you were a king, it was your job to roll out the propaganda machine to make sure that they didn't think it was you. So there are a couple great examples of this, and the first ones I'm going to mention all come from around the time of Jesus. So Julius Caesar was assassinated in 44 BC. A bright comet appears right after Augustus Caesar becomes emperor. Knowing that people would speculate that this bright comet in the sky was foretelling his death, Augustus Caesar decided to seize the moment. And rather than let people believe it was predicting that he would immediately be killed, he said that what you were seeing was the soul of Julius Caesar wandering through the sky. And to prove it to people, he commissioned coins And he put on the coins the comet and Dies Julius on the coin so that you knew that it was not predicting his death, but it was the soul of Julius Caesar moving through the sky. In 64 AD, at the time that Rome burned, the famous story of Nero fiddling while Rome burned, there was a bright comet in the sky. People in part thought that the great fire in Rome was brought on by the comet, or at least the comet foretold. It wasn't caused by the comet, but it was foretold by the comet. Nero felt exposed by this because there's a bright comet in the sky. So his answer was to make sure that other people paid the price. And he hatched, if not exposed, existing conspiracies. He hatched conspiracies about many eminent citizens of Rome and had them executed to state that the comet was predicting their death and not his. And he could blame them for the fire as well. During the reign of Vespasian in AD 79, a bright comet appeared. He claimed that it predicted the death of the Parthians, although he died later that year. So it did predict his. And maybe one of the most famous instances of all time is the Bayeux Tapestry, the famous Bayeux Tapestry, which predicts in 1066 William conquering England. And so the Bayeux Tapestry in 1066 shows King Harold II of England. And up there in the upper right-hand corner, you can see Halley's Comet, which was visible in 1066. Really bright, wonderful passage of the comet in 1066. And people believe that it foretold the fall of King Harold at the Battle of Hastings, when the Norman King William took control of England. In fact, the comet, because people believed that it predicted the fall of Harold, may have actually helped Harold fall. So, and anyhow, what bright comets were visible? Well, the Chinese astronomers tell us they recorded all these bright comets. So there was a bright comet in 12 BC, happened to be Halley's Comet, in fact. Halley's Comet has been seen and recorded in Chinese records as early as about 250 BC. So this was just one of the regular passages of Halley's Comet. It was visible for 56 days. There was a bright comet in 5 BC. So this is a little too early for our timeline. A bright comet in 5 BC, which is right perfect in our timeline, and then 4 BC in April. So there are 3 possible comets there. This is the path of Halley's Comet in 12 BC, so you can see that it actually moves across the sky. The dates are up there, so it actually moved this way. That's 8th of September, the 11th of September, the 21st of September, so you can actually see the comet moving through the sky as it orbits around the sun. All right. The last thing is to bring up astrology. That may be what the wise men saw, the astrologers saw that brought them all the way to Judea, was something that was predicted by astrology and not a bright thing in the sky. In other words, a gathering of planets like Kepler had seen. A planetary conjunction, or a close grouping of planets, were seen to be an astrologically significant event. And Kepler was exactly right that this triple conjunction of Jupiter and Saturn and Mars back in 7 BC would have been seen as a very significant sign by astrologers at the time. So horoscopes were often used by rulers, again, for propaganda purposes. Most rulers kept their horoscope secret because the horoscope not only told good things about you, but it predicted what your weaknesses were. But Augustus Caesar was so proud of his horoscope and felt that it was such a good horoscope that he published it publicly. And it predicted that he would be an unconquerable general. And he had a silver coin stamped with the sign of the constellation of the Capricorn, the water goat, with his name on it, Augustus, to let everybody know about his astrological sign. So there were groupings of planets visible in the sky around this time. I've mentioned this one, this triple conjunction of Jupiter and Saturn. What we mean by a triple conjunction is the planets pass close to one another 3 times. They pass close to one another, then close again, and then a third time they pass close to one another. And that happened around 6 and 7 BC. And in February of 7 BC, they were joined by Mars. So there was a third planet that came into the scene at that time. This was the one that Kepler thought was significant. It was also thought to be significant because it happened in the constellation of Pisces. And some ancient astrologers record that Pisces was the sign of Judea. And so this would indicate, and Jupiter, of course, is named after Jupiter, the king of the gods. Anything going on with Jupiter was a good portent for kings. And so if you have an amazing triple conjunction with Jupiter in the constellation that's associated with Judea, It could mean that there was a new king of the Jews being born. Another idea that's been put forth in more recent times is an occultation, a conjunction of the moon and Jupiter in the constellation of Aries the Ram. Michael Molnar, let me show you the picture here. Michael Molnar, an astronomer, is also a coin collector. And he noticed that in the time of around 10 BC to about 0, or there is no year 0, but there is astronomically, but about 1 BC, that in Antioch, they were minting coins that had a ram on them. And what he believes is that the ram represented Judea in the area around Antioch in Syria at the time, and not Pisces. And he has found other ancient astrologers that indicate the same thing. And what he found is that on the 17th of April in 6 BC, the moon actually passed in front of Jupiter. And it happened at a very auspicious time. If we look at the horoscope for that time, and I'm a professional astronomer and not an astrologer, and I will say that just to lay this out for you, that you know, I don't believe in astrology. I don't believe the positions of the stars on the day you were born have anything to do. They're not going to tell you whether today's a good day to make friends or get married or sign a contract. But it's important to note that ancient people did believe all of these things. And this is on that date that I just mentioned, April of 7 BC. This was the gathering of planets in the morning sky. So Jupiter and the moon were together. We had Mars and Saturn in that same part of the sky. They were in a part of the horoscope called the ascendant, which means that everything was magnified and was more important. And all of this was occurring in the constellation of Aries the Ram, which represented Judea. He believes that this was a much more significant event than that triple conjunction of Jupiter and Saturn and Mars, and that this was what predicted to the Magi that a king of the Jews would be born, and that's why they set out. What's most interesting about this one is it wasn't even visible in the sky, and that might explain why Herod and his astrologers missed it. This conjunction, there's the sun. You'll notice it happened very close to the sun in the sky. If you could mathematically predict where the moon and the planets were, you could predict that there would be this close grouping in the sky. But if you went out and looked at the sky, because they were all close to the sun and it was in the daytime sky, there was nothing to see. So he believes this idea that it was in the daytime sky is why Herod and his astrologers didn't see it, but the more sophisticated astrologers from the east were able to predict mathematically that this would happen, and that explains what the Star of Bethlehem was. So, the last thing that Michael Molnar points out is maybe we've been reading this passage wrong the whole time. So he points out that if Matthew understood astrology, he may have been using Greek terms in a way that astrologers would use them and not the way that lay people would use them. So terms like in the east or went before or stood above could actually be astrological terms. So he points out that in the east could refer to a rising known as the heliacal rise, when something rises right before the sun and first becomes visible. Went before could mean moving in the same direction in the sky, and the term stood above could also mean that it stood still. As these planets were moving through the sky, the astrologers would have noticed all these things, that it was visible just before the sun, that it was moving in the same direction as the sky and then stopped, and then planets go through this retrograde motion where they go backwards for a while as we pass them in their orbit, and then they go forward again. Maybe what he's pointing out is that Matthew was using astrological terms and not everyday terms. And so he says we should read it like this. When they had heard the king, they set out, and there ahead of them went the star that they had seen at its rising until it stopped over the place where the child was. When they saw the star had stopped, they were overwhelmed with joy. Maybe this is what it means. And behold, the planet which they had seen at its heliacal rising. It went retrograde backwards in the sky and became stationary above in the sky, which showed us where the child was. So that's his belief, that it was an astrological theme. So I've run through all the gamuts. There are lots more things if you're interested. There are people who believe it was the planet Venus. There are other planetary conjunctions that play a role, other things. But I think I will leave it with that because I'm already over time. So thank you very much. I'm happy to answer any questions you might have. So. Yes.
Let me get the mic to you so we can record this. Thanks.
So what do you believe is the answer?
So, yeah, no, it's a great question. I'm going to have to go by far with pious myth or midrash. So, and the reason I think this is Matthew seems to be working very hard to hit all the major points of the Old Testament to say that this was the birth of the Messiah. And so of all of these, I go most of all with a pious myth. I think it's also interesting that, at the time that Jesus was born, people probably weren't recording the details of what was going on. And so his seems to be a very detailed account for something that happened long before he was writing. Almost, in my opinion, too detailed to know exactly what was going on. So I'm going to go with the pious myth.
So if Halley's Comet was seen back in 2,000 years ago,
yeah.
repeatedly, what is the life expectancy of that comet or other comets, and how can they burn for so long, or maybe it's not very long in terms of astrological time? But
yeah, in astronomical time, it's not very long at all, but in the course of a human lifetime, of course, it's a long time. So every time Halley's Comet comes around the sun, it loses many meters of ice off of its surface. Right. But it's about 6 kilometers or so, about 10 kilometers roughly in size. And so there's a lot of meters there. And so it will last for thousands of years to come. But we absolutely see smaller comets as they pass close to the sun. They finally break apart. And we've seen many, many comets that just eventually fall apart and disappear.
So what differentiates a comet from a star?
So a comet is a little tiny ball of rock and ice. A star, in the modern sense of a star, it is a huge physical ball of gas like our sun. To give you an idea of how big the sun is 100 times the diameter of the Earth, which means 1 million Earths would fit inside the sun. A comet would fit comfortably in Charlottesville. So that's the difference. Stars are huge, planets are small, comets are tiny. So yeah. But when you look at things in the sky, it's not always obvious what's going on. It wasn't obvious to them. It is to us today. So.
Come on over here. Let me get the mic to you.
Thanks. I'm curious, when you were talking about the nova that was visible in the southern hemisphere, and you had those 2 photographs of the star that exploded. Over how long or short a period of time was it for the nova to materialize? Was it sort of like a spontaneous thing like the Big Bang, or did it sort of evolve over a period of a day or several days?
Great question.
Or do we know?
Oh, no, we know. Yeah, so in that particular case, we know quite well. So a supernova will typically increase in brightness within a few hours. It'll take a couple days to get, or many tens of days to get up to maximum brightness. But that particular supernova was literally within a few hours. It went from not being visible to being visible. A Canadian astronomer quite famously was working in an observatory in the southern hemisphere and had been out earlier that night and hadn't noticed anything, and went out and looked at the Large Magellanic Cloud and saw a star that he'd not seen there before. So within a few hours, that star increased in brightness. It then continued to increase in brightness for many days, and then once it reaches its peak brightness, it decays over many months and years to come down in brightness. But supernova happened within a few hours. Yeah. The core collapse, the collapse of the core of the star actually takes a few seconds. But that shock wave takes a few hours to work its way through the atmosphere of the star and get out to the surface.
So I also had a question about the nova. You mentioned that there's like spectrographic information that you can pull from the surface.
Right.
Is there information that you can pull from the surface over time that tells you about the interior of, or it could be predictive about the interior information that you might be looking for?
Absolutely. Yep. Over long periods of time, if you study a star in very detail, we can actually see stars pulsing, and that pulsing can actually tell us what the interior structure of a star is like. By measuring the surface properties, we can tell exactly what elements it's made of, and by looking at, from that, we can derive the size and the age of the star. And often can make a good estimate of its mass. So we can tell a lot of things about it. What we are not able to do right now is to predict within a day to when, this example that I gave, to predict that star is going to explode tomorrow. But with many stars, from looking at the pulsing of the surface, we can actually tell what's going on deep down inside the star. This is best been done with our own sun. We've got terrific models of what's going on deep down inside the sun because we can see patches on the surface of the sun pulsing up and down. And those pulses are sound waves, and as those sound waves travel through the sun and come out the surface, They probe what's going on deep down inside the sun.
Am I correct in thinking that scientists can tell what minerals, what materials are in stars
Absolutely.
by the color of
So the color of a star tells us its temperature. The way we tell what elements are inside of a star is by breaking the light into its component colors. And what I mean by that is taking a spectrum of it. And then in each individual element absorbs and emits specific wavelengths or specific colors of light. So, for example, hydrogen in the visible part of the spectrum emits and absorbs a red color of light, a blue-green wavelength of light, a deep blue wavelength of light, a deep purple wavelength of light. So if you see that particular pattern in a star, you know that it's got hydrogen in it. Now, hydrogen, most stars are 74 or 75% hydrogen, so it's quite a common thing to see in stars. So most stars are about 74% hydrogen, 25% helium, and about 1% everything else.
Well, thank you. We're going to wrap up so that you guys can get outside. And before you head out, we've got some hot chocolate and cider and cookies. So grab that. And we want to thank Professor Murphy for speaking on behalf of Lifetime Learning. We have a small token of appreciation. Give him a hand. Thank you.